Hi there, Math 20-2s. How's it going? So today, in this video, we're going to go over this quadratic practice question sheet here. Just talk about some of the things I'm going to expect maybe during the exam. If you're watching this video, then maybe look at some hints. All right, so let's start it off. So these first two questions, they're just typical word equations. They just want us to figure out, sorry, let me just get my coffee here. Want us to figure out what t is or what value is, but it doesn't specify. So when it comes to these word equations, I'm going to give you the equation. So you can see right here, the equation is already given to us, right? It's an equation because it's equal to something, right? So I can use the quadratic formula, I can try to factor it, but because it doesn't specify how to solve it, might as well just pull up the graphing calculator here, the trusty old graphing calculator. Let's clear some stuff out of this thing first. I'm going to just go back to zoom normal there. So if your zoom's ever messed up, so always go zoom number 6, and now let's put you back to like this 10 by 10 window here. All right. So what we're going to do is I want to graph this equation here. So this is going to be a bit tricky. I'm just going to move that to the other page. You can't see it. So I'm going to go y is equal to. And the equation says, oh, maybe the first thing I should do is actually make this equal to 0. All right, so I'm going to want to, get rid of that. I'm going to want to, before I start the question, make sure this thing is equal to 0. So I'm going to minus over this 1.5. Oh, this is going to get kind of annoying, that little thing there. All that pops up there, but no, not all the time. Some of the time there. All right, so I'm going to minus this over. You're going to group your like terms. I know I put it here, but actually it should be over here when you do it. So let me just erase that piece there. So I minus that, and I get negative 0.1. Now it's equal to 0. Okay, so the whole reason to do that is so when I put it in my graphing calculator, my second equation, because I'm going to find the intersection here, because I made that side equal to 0, my second equation is also equal to 0. And then I can just type in exactly what I saw before, but instead of t's, I'm going to put x. And it's kind of nice, this little button here, this xt theta n button, right there, has a t beside it. Doesn't mean there's a t. If you change the mode of the calculator, you can get a t out of that, but don't do that. So I'm going to type in everything except for t's. I'm going to put x's, and 0.1. Okay, so it looks like that's what I see. I hit graph. So there's my graph here. So I got two positions here that I'm going to have to find. So my head's kind of in the way, but you can actually see the x-intercepts here. So what I'm going to do is I'm just going to go second trace number 5, enter, 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 and then I got one answer. Okay, so 0.00, let's do the nearest hundredth. So you're going to see why that is important here, about 0.004-ish. So right now I got t 0.00417 something. All right, seconds, because t is in seconds. I'll put that there for now. I'll just reiterate that later. And then I'm going to do it again, second trace number 5, so intersect, enter, enter. As long as you have that 0 in the y2, enter, enter should work. Now we're here, it says guess, so I'm just going to count over 1, 2, 3, 4, 5. Let's type 5 in, see what happens. Oh, so I moved it off a little bit, so it's 4.89. 4.89 seconds. All right, so when it comes to these word equations, now once we find our answer, and just by graphing it seems like the best way to do it, now we have to kind of analyze our answers and determine, do these answers make sense? Like if this wasn't a word equation, these would both be my answers. I'm good. Found two answers. You have to round it to the nearest hundredth. But if I look at the context of the question, batter hits the ball straight up. The infielder catches it some distance away, right? But 1.5 meters above the ground. Which one of these makes sense? Does it make sense that the ball was in the air for 0.004 seconds, so like 4 microseconds or milliseconds, sorry? Or does it make sense that it's in the air for 4.89 seconds? So if it's a high hit, the 4.89 seconds makes way more sense than a fraction of a second here. This would be like the guy was immediately right above the batter and caught the ball as it went up, right? Not as it came down. So I'm going to just lightly cross this answer off. I'm going to box around this answer. There we go. So I like to include my answer, both answers. I don't want to erase one, just kind of show that I thought about the process. I found both answers, crossed one of them off. Okay? So that's what's going to happen on this next one too. So the next one, we're going to make it equal to 0. Now when I make it equal to 0, honestly it doesn't matter what it looks like. So 16 minus. So if I minus over this 285 to the other side, I'm just going to stick it on the end here. I'm not going to multiply the whole thing out. I'm not going to try to find the distributive property, group terms, and then try to factor it or use the quadratic formula. It doesn't specify how to solve it, so I'm just going to graph it. And if I just minus that piece over, I just graph exactly what I see here, and I get my answer. So let me just go here. I'm going to clear out this one since I made it equal to 0. I'm just going to keep the y2 there being 0. And then I'm going to go bracket 12 plus 2x, bracket, bracket, 16 plus 2x. I'm not too concerned about how the formula came to be, like why does it look like. If you want to read through the question, you can probably figure out why they used the 12 and plus the 2x thing. But I'm just trying to solve it, so they just gave us the equation. Plug it in. I'm going to hit graph here. All right. And I see one answer here. And then I'm going to, it's quadratic, so usually there's going to be two answers. So I'm going to go to zoom. I'm going to zoom out. There's my two answers. All right? I thought the answer was going to be over here on the right side, but it actually ended up being the left side. So second trace, number 5, enter, enter, enter. Okay, so 1.5. So I'm going to put that answer over here. X is equal to 1.5. And then we'll do the other one. Second trace, and enter, enter. And then the guess. So I know it's in the negative realm. I don't know. Let's just say negative 12. Negative 15.5. If it went back to the other one, just guess even less. Or you could just cursor over it by using the arrow buttons to move your cursor around. Negative 15.5. That's what we got here. Okay, so I left a little space here because I want to read through this. It's in meters, meters. So it looks like X is going to be in meters. Then I had to analyze this quickly and not really quickly, I had to analyze this and determine, do all these answers make sense? Can I have a negative length? Probably not. So I'm going to cross that off. So it makes more sense that the width is 1.5 meters rather than negative 15.5. Even if it was positive 15.5, still wouldn't make too much sense. Right? That's just way too big based on the picture, but the negative doesn't make sense in it. So let's just cross it off. If I still wrote it down, I like to write those answers down. All right. Now, how I changed this question looks very similar to what's actually on the test, but how I changed this one is I don't really care too much about the discriminant on this kind of question. I really just care about what the number of solutions, right? I can use the discriminant to determine the number of solutions, but I can graph it, I can do lots of different things to determine the number of solutions. All right. So it's up to you. I'm going to use the discriminant because it's a good thing to practice. Nice to know what the discriminant means. So remember that the discriminant is the b squared minus 4ac part. So I'll actually unerase that there. Okay. So for this first one here, you got your a, you got your b, you got your c. So it says b squared, so that's 16, because 4 squared, minus 4 times negative 2 times negative 6. It doesn't matter if the a is negative. Most of the time when I'm factoring, I don't like to have that beginning thing negative, but so it doesn't matter when you're using the quadratic formula. It's got to be equal to 0, though. So you got to make sure it's equal to 0. So 16 minus 4 times, I get negative 32 here. Yeah, negative 32. Okay, because it's negative means there's no solutions. Okay. in the quadratic formula, my head's in the way, right here. Oh no. Just cross that off. In the quadratic formula, if I'm trying to take the square root of something, and this is remember the b squared minus 4ac is underneath the square root. If it's negative, I'm not going to get a solution. Okay? Question 2. Okay, so 2, we have an a, we have a c, but you notice the b is the one that's in front of the x. So if you don't have a b, we just assume it to be 0. So this technically is 0 squared minus 4 times 3 times negative 6. And what we get here, if I can do this correctly, so we get 72, positive 72, because there's 2 negatives in there. So it ends up being positive 72. Because it's a positive number, there are 2 solutions to this one. Okay, let me just put an arrow here. All right. So we do the same thing. The next one, you notice that the b is 0 again. We've got 4 times a times 6, but this time we get negative 72. So, no solutions because of that negative. Okay? And the last one here, we got to make it equal to 0. So if I rearrange this ever so slightly to start off with, add that 4 over. So I'm just going to plop that 4 over, add it over, but there's no like terms to that, so it kind of just adds onto the end there. And technically, I could factor this. I might as well factor it. Let's just double check something here. You could use the discriminant, but I'm not too concerned. Like if you can find how many solutions there are some other method, go ahead. So x times x, 2 times 2, plus and plus. Looks like I just got the one solution because they're both exactly the same here. So we have one solution. Now if you wanted to do this by the discriminant method, okay, I would say b squared, so that's 16 minus 4 times 1. That's kind of backwards. I know the a and the c. Sorry about that. But 16 minus 16 equals 0. Because it's equal to 0, we have one solution. But over here, I determined this is the one solution right here. Now I did that. I solved it by factoring. Okay? That's what I want to do in the next one here. I want to solve these by factoring. So if I'm going to solve this next one by factoring, we want to make it equal to 0 first. So let's make this equal to 0. Add that 7 over, and continue on. So we've done many of these. The first thing you always want to do is you want to look for that GCF. So I'm going to factor the 7 out. Okay. Then I'm going to look for what multiplies out to 1 and adds to the middle number, negative 2. So x minus 1 and x minus 1. Now this little 7 in the front doesn't matter. If there was an x beside it, then it would matter. Then it would be a 0 as one of our answers. Because it's just a number, we can actually kind of ignore it. It really doesn't do too much. We just kind of get rid of it if we want to. The set of brackets, though, those are allowed to change because I could change the x. So if the x was equal to 1, then this whole thing would equal 0. And then over here, same thing. If x was equal to 1, because 1 minus 1 is 0, that would be one of my answers. So I only have one solution here. Kind of like that one above it. When we do that discriminant one, if I did the discriminant, I would have got 0 as well. So just like the other one, we want to make this equal to 0. So we're going to minus over the 3x to start off with. So I got plus 2x instead. It's equal to 0. Factor, 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 factor. Only one way to get x squared is x times x. Then I have 7 and 5 plus 7 minus 5. Okay? Remember, you always want to find out what would make this work. Like what would make this top equation left side equal to right side. So we're looking for solutions here. So what would make, say, the second set of brackets equal to 0? Well, 5 minus 5, so 5. And negative 7 plus 7 would make that other one equal to 0. So we're always looking for the solutions. All right? It says by factoring at the top, so very key. You've got to factor this one out. So yeah, I could solve for x by rearranging x if there's only one x, like this next one, but it wants me to factor it. So I had to recognize that this is a difference of squares. There's no GCF. I can't divide everything by 4. So what you do is you take the square root of both these numbers, and they have to be in a very specific order. Since the 4 is first, when I take the square root and get 2, I have to write that first. If the 25 is last, I have to make sure to write the 5 last. All right? 1 plus, 1 minus. Okay. So once I have that kind of factored out, we've got to figure out what the answers are. What would make this equal to 0? And it seems like, oh, I see a minus 5. Why can't I just put a 5 in there? But if I did put a 5 in here, 2 times 5 is 10, minus 5 is 5. That's not 0. It ends up being 5. Put a 5 over here, or negative 5, you get like negative 5. So to figure out what it is, you have to think of what's running through my head at this point. I want this to be equal to 0. 2x minus 5. I want to be. So I'm just going to write it equal to 0. I've got these numbers going through my head right now. This is in my head. So I'm going to add over the 5 first. I'm just going to solve for x here. And then divide by 2, divide by 2. Those are my answers. 5 over 2. Then you do the same thing with the other one. And you don't have to show this step if you're really good at this mental math. But sometimes I do it just so I don't make mistakes. So divide by 2, divide by 2 here. Those are my answers. Negative 5 over 2. Cool. All right, I'm going to put a little box around that. Now remember what I said, we don't have to know how to factor complex trinomials, really. We practice them because it's nice to know how to do them. You don't have to know how to do them in Math 20-2. So if I ever ask you want to try to solve one of those, then it's probably already going to be factored for you like this next one. So we just have to look at these and say, okay, this one I would add over the 7 and then divide by 2. So I like add the 7 then divide by 2. So in my head, that's 7 over 2. The next one I would like minus the 5 over first and then divide by that 7 that's there. Right? So that's what I'm doing in my head. Right? You don't have to write it on this side. You can just write down the 2 answers over here. It's already factored for you. It's really easy to do. And there you go. That's pretty good. This one here says use the quadratic formula to find the answer expressed to the nearest hundredth. All right, let's see what we have here. So I'm going to pull up my calculator eventually. But to use the quadratic formula, it's got to be equal to 0. Just like factoring, just like graphing, you want them to be equal to 0. So I'm going to take this negative 10 here. I'm going to add it over to both sides. All right? So negative 2m squared minus 7m minus 3 is equal to 0. All right? So once I have that, I can list off my A, B's, and C's. Like I said, you don't have to do this one. You don't have to list them off if you don't want to. I do just to make sure I have the proper signs for these things. I think I do. Yeah, looks pretty good. Once I have that, I'm going to solve for m here. And m and x are interchangeable, so I'm solving for that. Negative 7. Remember, the formula says negative. I don't know if you can. No, it's not above my head here. It's over there somewhere. All right. But negative 7. So it turns to a positive 7. Even though it says negative b on the formula, because I got 2 negatives, it's going to turn positive. Plus or minus the square root. 7 squared. No, I didn't say negative. But remember, you square a negative, it turns positive anyway. So 49 minus 4 times 2 times negative 3. All right? And then divided by 2a. Now 2a is just 4. Okay? Plus 7 plus or minus square root. Now this one I'm just going to type in my calculator. 49 minus 4 times, let's say, 2 times negative 3. So 73. All right? Keep that up there because I might need my calculator for later. 73 all over 4. Okay, I kind of made that big deal a little bit large there. Cool. All right, we're going to keep on going. I think I have lots of space in this question. What do I do? Oh, it's the last question. Okay. It says to the nearest hundred. Okay. Because 73 is not a nice number. It's actually a decimal. If you want to type it in, you can. It's got a lot of decimals to it. It's like 8.54400. So 8.544 all over 4. Because there's all those decimals and stuff, I might as well just go back to the previous line and just do that calculation twice. The root of 73, and then round my final answer. So I'm just going to kind of cancel this one out here. So I'm going to do two calculations here. I've got 7 plus the root of 73 all over 4, comma, 7 minus the root of 73 all over 4. That looks like a minus. I'm just going to do that. Go right. There you go. All right, so I'm going to find both these answers. So 7 plus the root of 73. That did not work at all. 73 bracket, get on the bracket, there we go. Divide by 4. I think that's right. Yeah. We hit enter. So 3.89. Okay, let's put that down. 3.89. It says nearest hundredth. That means 2 decimal places. All right, so that's 2 there. And let's do the last one here. I take that equation. I'm just going to change this plus to a minus sign here. Negative 39. Negative 0.39. Negative 0.39. Okay, then you might be thinking, oh man, I got to verify these. I don't know if I did this correctly. I think I added the 10 over just fine. I think I can go negative 13 plus 10. Get negative 3. So I think this line is fine. So what I'm going to do is I just want to verify, do these look like they could be proper answers? All right? So I'm going to graph this. So 2x squared, this is the double check, minus 7x. This is me verifying, right? You don't have to do verification algebraically. You don't have to put the numbers in. You can verify it some other way, then go ahead. So I graph it. Okay, let me just zoom back in. So zoom number 6 right here is their standard, so I'll just hit 6. Okay, these look like they could be right. Let's double check. So the second trace 5, enter, enter, enter. Hey, there's that number right there, that negative 0.39. Yeah, that looks good so far. Thumbs up. Where's my thumb? There it is. And then second trace 5. I don't know what I just hit there. Second trace 5, enter, enter, 4. So I guess 4. Hey, there's the other answer. At 389. Yeah, there we go. That was just a quick little verification on my calculator. At least I did this correctly. I don't know if I did the first step correctly. I can go back and try to verify it with the original equation. I think I can rearrange correctly. This looks pretty good. All right, so that was the first worksheet. I'll come back and do the second worksheet with you in a second. All right, and I'll see you soon. Later.